Hey guys, John the Quant here. Hopefully you just came from a video where we went through Apple's most recent Form 10K filing with the SEC, and we saw that there's a ton of great information in there. But the question at the end of that video was, how can you find that information on hundreds or even thousands maybe of companies without spending thousands and thousands of hours on it? So in this video, all we're going to do, we're going to go to Colab, and I'm going to show you how you can download all that information from SEC's Edgar service, and then we'll just, pull some information out of it and draw some plots, and that'll be it. I'll meet you at the computer. And we are getting the SEC filings from Edgar. All right, here, this link takes you back to the website where we looked it up manually before. And these are actually super easy to look up because of the extensible business reporting language. All right, and everybody uses it, and so all the filings have the same kind of format. It's pretty great. All right, let's get into the code. We're going to ignore warnings. We will need pathlib to make file paths and pandas to work with data frames. I like tqdm. It just kind of lets you keep track of big loops, how long they're taking, and everything like that. It's fantastic. Now these ones, requests, URL lib, the zip file stuff, and IO. Those are all used. It all comes in as zip files, and then we're going to use all of these libraries and functions to open them. The metadata comes in as a JSON, and then we're going to want to be able to print it, and we're going to want to be able to make plots. So I started off by setting this path to where I wanted to save all the data, and it really needs to be off on its own because it ends up being a lot of it. So you don't want to, clutter everything up. Then you'll need the URL to the SEC. Then you'll need the path to the files. And I just made this list of all the filing periods that I was interested in. I went from the beginning of 2015 to the end of 2020 quarterly, and got this 4 quarters per year, and 1, 2, 3, 4, 5, 6 years, 2015 through 2020. Then for each of those years and quarters, we had to create a path to save the file. You have to make the directory if it doesn't exist. Then you'll need to put the entire filing URL together. And then over here, you're opening the zip file on the internet still, and then reading it in and saving it. And that took probably about an hour to run for this whole thing because there is a lot of files, which hopefully you'll get to see later. And to speed up data access, I changed those. They come in as TSV files, tab separated values files, which read in pretty slowly. So in order to change that and kind of speed up access, I switched everything to Parquet files. If you watched the video on the different file types and read and write speeds, well, you'll know that HDF5 was faster when the data was strictly numeric, but since we've got a lot of text data in here too, Feather or Parquet was better, and I ended up going with Parquet this time. I forget why exactly, but I remember thinking that Parquet was the way to go, so hopefully you'll just trust me on that. So I went through all these files, and I just changed them all to Parquet, made new paths and everything, and just switched it over. That also took quite a while, so I don't have to do that again. Then the data, it comes with metadata. And so for the year 2015 in quarter 1, I found I opened the metadata JSON file. And that tells you all about the table schema and data types and just a whole bunch of different things. If you want to look through this, it will really help you figure out how to work with the data. How is it structured inside? Honestly, I don't think the structure is that difficult, so I didn't work with that too much. Okay, so each quarter the data comes as 8 separate files, okay, or 8 sets of files. So you have sub, which is submission and identifies the company, form, date, and so on. Tag, which explains the taxonomy tags. Dimension provides additional details for numeric and text data. Num is numeric, and it gives you 1 row for each distinct data point in the filing. Then text has all the text fields. Ren is for rendering. It helps it render on the SEC website. Now, we're not going to use that, but you probably could if you wanted to make things look pretty. Pre-presentation gives even more details, and cal shows how different tags are calculated. And right now, we're going to worry about sub, which is submissions, num, which is numeric, and maybe a little bit about text. But I think, honestly, in this, I ended up only working with sub and num. So we're going to grab submission information. So we're going to read in, this is just the fourth quarter of 2020, the submission file for the fourth quarter of 2020, and it has 16,113 filings in it. Okay, over 16,000 filings in the fourth quarter of 2020. But how many uniquely named filings were there? So name refers to the name of the company, and there were only 5,845 unique companies. And then we're going to use the filings for Charles Schwab. And how I came up with that was I just started with subdata name.unique and just started looking through and trying to pick out a company that I was interested in looking more into. And I came up with Charles Schwab right here. So company name is this. Needs to be the same thing right there. And I went through all of the submission data where the name was equal to company name, transposed it, dropped missing values, and then used the squeeze function. And we'll talk about what the squeeze does in a little bit. And then I knew the columns that I wanted. I didn't want all of the columns. Look how many columns there are. I knew I didn't want all of these. So I just picked out a few good ones. And looked up. Now I've just got Schwab and those important columns shown right here. You can see there's 1, 2, 3, 4, 5, 6 filings, okay, in the fourth quarter of 2020. That's 1, 2, 3, 4, 5 8Ks and a 10Q. 5 8Ks, that means 5 special events happened in the fourth quarter of 2020. And I believe one of those was their purchase of TD Ameritrade, which is huge. But 5 special events seems like a lot for a single quarter. They had a big quarter. And then 1 10Q, which is really the kind of filing that we're interested in. Now we're going to go through and we're going to build a fundamental time series, all right, with information from the 10Qs and 10Ks between 2015 and 2020. So I started with an empty data frame, and then I went through these submission files, all of them. All right, read them in. Then I used temp sub, the CIK up here. This is a company identification number. So I found all of the submissions where the CIK number is equal to Schwab's CIK number. And I also knew that I only wanted the forms 10Q or 10K down here. All right, read them in, concatenated everything. It also took a while, but not that long. And I ended up with 18 10Qs and 6 10Ks between January 2015 and December 2020. Now look at just the first 5 rows of that data frame. You can see this ADSH number, and that refers to a specific filing. Then you've got the CIK number, tells you that it's Schwab. The name tells you that it's Schwab. This SIC, I think that is another identification number, but I'm not certain. Then it's got all this information about where the company is located. It's got a telephone number for them, and just a bunch of other information. And we're going to use that. Specifically, we're going to use this ADSH number to find the numerical data that goes along with these filings, because they're in different files. So we're going to get the numerical data. This is just what one numerical file looks like. This is the first quarter of 2015 numerical file, just the head. So this ADSH number, which I said before, refers to a specific filing. That's what we're going to use to pick out the numerical data that goes with Charles Schwab. So here, Schwab, numeric, empty data frame, then go through all of the numeric files, read them in, and we're looking for numeric rows where the ADSH number is in Schwab's ADSH numbers. And I kept track of the length of this data frame as I was going to make sure that it was, I was getting reasonable numbers. I wasn't getting zeros and I wasn't getting, a million or something. Now this tag column, if we can go back for a second, this tag column tells you what the number refers to. So all of these are about accounts payable and current. Then you've got, of course, a date and the numeric value. All right, let's go down here. After you've gathered up all of the numeric data that has to do with Schwab by linking the ADSH numbers together, and that took a while, definitely took a while. Let's look at that Schwab numeric data frame. Here we've got the ADSH numbers, then the tag, okay? So this tells you what filing, this tells you where in that filing, what does the number actually refer to, then the date and the value further on. I don't think we're worried about the rest of this stuff. It's all basically zero anyway. But this date, this is December 31st, 2013, but we want it to be an actual date, which is what we did in this line. Look at it again, changed it into a date format, and then save it so that you don't have to do that all again because this stuff takes forever. All right, let's look at the info. We've got now 45,852 observations, numerical numbers, from Schwab for the last 6 years. And we're going to use those to find the price to earnings ratio and the earnings per share. And very luckily, Schwab hasn't done a stock split since May 30th, 2000. If Schwab had done a stock split in our window from 2015 to 2020, then we would have to adjust these numbers for it. Or we would have to at least worry about if they had been adjusted, but we don't have to care because the last stock split was 21 years ago, which is crazy. All right, so to get the earnings per share, we can just grab those from the numeric data frame up here using the tag. So here we're going in, EPS is, we're going into the numeric data frame and we want the tag to be equal to earnings per share diluted, and we want it to be the first quarter. We're only caring about the first quarter for whatever reason there, and then we're going to get rid of the tag and dim H columns. Then we'll group it by ADSH number, and the ADSH number, oh, I see what happened. This isn't the first quarter. This is for 1 quarter because it had, if you recall, the 3-month or 9-month values. So that's my bad. I explained that poorly. I'm sorry about that. All right, so here we're going through. We're going to group it by the ADSH number. Okay, so we're grouping all of the numeric values together by the form that they're in. And we're keeping only the most recent form. Okay, I know that that sounds complicated, but the ADSH numbers are repeated, and we only want to keep one of them. All right, so that's what we're doing here, basically. We're keeping only the best, the most recent, the last filed in case there was an amendment or something, ADSH number. And then we're keeping only the value and the date, and then we'll set the date as the index, and then now let's talk about squeeze. So here we had 2 columns, value and d-date. Then we made one of those, okay, we made d-date the index, so now we have only 1 column left. So this right here gives us essentially an n by 1 matrix, okay, n rows in 1 column matrix, where each row is referred to by d-date and the column is referred to by value. This squeeze function takes that n by 1 matrix and it takes any dimension where the value, the size of that dimension is 1, and it compresses it. So we started here with an n by 1 matrix, and then we compress that column dimension until essentially what we have left is a vector of values, just a vector of length 1. So it just makes everything smaller in computer terms. But what it's actually doing is it's compressing the dimensions where the size is 1. And then we'll sort it just to get everything in the right order. And then plot that. And this is what the earnings per diluted share looks like from quarter to quarter for Schwab. It starts off pretty low, and then it goes up, and then it kind of came back down going into 2020. Now, for the price to earnings ratio, we are going to have to use stock prices. You can get them pretty easily from Yahoo Finance. Now, Yahoo's API doesn't work anymore, and Pandas Data Reader wasn't working for me. I think there's a fix to it, but it's really easy to just find them using the URL and download it. So that's what I did. We've got the date, it's daily, OHLC, adjusted close, and volume. Now I turned the date into a date time data type, and then set it as the index. All right, 1,447 non-null values in the OHLC. All right, now to calculate the price to earnings ratio, all we had to do was take the adjusted close. I made it to a new data frame called price, and then joined it with the earnings per share data frame. And then I used the forward fill to fill in any empty spaces, and then drop whatever was left over. And then the price to earnings ratio is the price divided by the earnings per share. Price per share divided by earnings per share. And that comes out here. And we plotted that. You can see it looks pretty crazy, and it takes a big dive right at the beginning of 2019. And you got to wonder why that is. And so we're going to look at more plots in a bit to kind of figure that out. So here, just made 3 plots close together. This is just the adjusted closing price. This is the earnings per diluted share. You can see it jumps up in this quarter. Between the last quarter of 2018 and the first quarter of 2019, their earnings went way up. And that's why you have that price to earnings ratio drop down. So the price to earnings ratio, if it's relatively high, that indicates a stock that's expected to keep growing, right? Whereas if it's relatively low, that means this stock is relatively cheap compared to how much the company earns. So it going down is not necessarily a bad sign or a good sign, although lower price to earnings ratios, they do tend to outperform a little bit. So this dive is actually kind of a good thing, maybe. It really depends on your risk preference and your investment style. So look at a bit of other things in there. Just looking at all the different tags. There are 856 different tags in here, and most of them were available for sale securities and debt securities, or loans receivable, fair value disclosure, all kinds of different things. But there's 856 different tag fields in that numerical data that you could then find and work with super easily using this method. So let's look at some dividends. All right, we'll go through. We're going through the Schwab numeric data frame, and what we're doing is we're using a regular expression, or a little regex thing here, to look for tags that talk about paying dividends. All right, so this says 0 or 1 characters, any character, 0 or 1 of them, and then pay, any characters, 0 or more of them, and then div, and then other characters are allowed after it. And then I only want the tag, ddate, and value columns. And now I'm looking at just the tags that it gave back, and the 2 that it gave were payment of dividends or share-based compensation arrangement by share-based payment award fair value assumption expected dividend rate. Whew, and that's quite a mouthful. So we ended up using this one. All right, literally the payment of dividends. So Now we just want to keep the dividends where the tag was the payment of dividends. We'll drop the tag column and group it by date and just take the average. Now this shows an error because I ran things kind of in the wrong order right before showing you this. It will not run an error if you just run straight through this with exactly the same code that I've got. All right, now, so what this actually gives us is going to give us is the total dividends, not how much dividend does each share get, but how much total did they pay. So in order to find out how much each share gets, we're going to need the number of shares. So we'll find the weighted average number of diluted shares outstanding, okay, using the tag, and we'll need the d-date and value of that, drop all the duplicates, group them by the d-date, and get the mean here. Now dividends per share is going to be the dividends divided by the shares, and then drop anything where it's where the value is missing. And we ended up with 29 non-null values there. And then we just plotted that. You can see how the dividends per share kind of changed, and they seem to go up lowest in March, then they go up and up and up, and lowest in March and up and up and up, and lowest in March and up and up and up. And look, they got pretty big in 2019 whenever the earnings per share was pretty high. And they fell back down, but they're still actually pretty high. All right, if you watch the last video, this dividends per share of 0.8 is much higher than Apple's of 0.2. All right. There it is. That's all there is to it. Hopefully you guys can see how easy it is to pull out SEC filings using that Edgar service, and how easy it really is to just kind of parse everything in Python and get some great indicators. And I definitely recommend that you guys try this stuff on your own. And you know what? Probably later what we're going to do is we're going to pick a small, probably, universe of stocks, and we're going to do this for all of them. So we'll be drawing earnings per share time series on, say, 20, all right, small universe, 20 different stocks, so that we can compare all of them and things like that. Or maybe we'll go big. Who knows? We'll see. So if you enjoyed the video, please let me know. If there's something that I'm doing badly, I'd like to know about that. If you learned something, go ahead and like the video. If you want to keep learning with me, just go ahead and subscribe, and I'll see you guys next time.